Okay, so we're going to do the notes on section 6.1, which is about absolute extrema. Extrema are maximums or minimums. So we're looking for absolute maximums and absolute minimums. So this is the definition. I'm going to draw a super rough sketch and then we're going to dive in and find some of those absolute maximums or minimums. So if I have a function and it does whatever it does, so my function looks like this, and it's on a closed interval. So it's only being considered between these two values in X. So we're only looking at this part of it, could do something outside of there. So you can see at a glance that there's a maximum here. That's the tallest value. There's a minimum here. That's the lowest value. So I'll call those X coordinates A and B. So we're considering an X coordinate C on the interval. So in between these X values, then that occurs is a maximum if the f of c, so the y value, is greater than all the other y values. And you have a minimum at x equals c if the y value at c is less than all of the x values. So let's see if that's true. So f of a, this a coordinate here, you can clearly see that f of a is above, so greater than or equal, but greater than, it's definitely greater than all the other x's, greater than all the other y's for every x. And we have a minimum. It happens to be at the x coordinate b here. That's a minimum. You can see that it's a valley. And that y value, f of b, is less than or equal, it's not equal, than all the other y values between here and here. So f of a is a maximum, and that and that maximum occurs at x equals a, and f of b is a minimum, and that minimum occurs at x equals b. So I talked through this whole thing. Let me write it out again. So if I have a, f of a, and we're talking about it being a maximum, then we say it this way. There is an absolute maximum, I'm abbreviating, at x equals a, and the maximum is f of a, the y value. And then at b, f of b, so that was our minimum, there is an absolute minimum, again, I'm abbreviating, at x equals b, and that minimum is f of b, that's the y value. It's important to tell the difference between an x and a y. All right, we've got an extreme value theorem. If you're considering a function that's continuous, meaning you can draw it without lifting your pencil on a closed interval, so in between two x values, it will have both an absolute maximum and an absolute minimum. We're going to trust that that's true. And here is the procedure for finding the absolute extrema, so the absolute maximum and the absolute minimum, only on a closed interval. So you find all the critical numbers. So you do that by taking the derivative and setting it equal to 0. Evaluate the function for all critical numbers, meaning find the y's. Evaluate the function for the endpoints, so at a and b. And then the last step, the greatest value for y's found at critical values or endpoints is the absolute maximum, and the least for the y's is the absolute minimum. So we're going to go ahead and do these on the back side. So if we turn the paper over, and remember that the first step is to find all the critical numbers. So we do that by setting the derivative equal to 0. So the first thing we're going to do is find the derivative. So the derivative of this function is 8/3 x to the 5/3 minus 32/3 x to the -1/3, and we're going to set that equal to 0. my best bet for finding the x values for this is to factor. So if I factor out x to the negative 1/3, I'll have a constant here. That seems like it would make it easier. And I have a common factor here of 8/3. So factor out 8/3 x to the negative 1/3. So that gives me a coefficient of 1 here. And I have x to the 5/3 minus negative 1/3. So that would be 6/3 minus 32/3 divided by 8/3 is 4. And we factored out the x to the 1/3, so we don't have an x here, equals 0. So this would be 8/3 x to the negative 1/3. Sorry, it's positive now that it's in the denominator. Times x squared minus 4 equals 0. So x/3, that x is in the denominator, so it's not going to have a 0, but it's going to have a critical value at 0 where the denominator is undefined. And then x squared minus 4 factors into x plus 2 times x minus 2. So I'm also going to have x equals -2 and x equals +2. So those are the critical values. And then we want to evaluate all of those. But remember, we're on the interval between -1 and 8, and -2 is not in that interval. So I'm not using that one because it's not in the region we're considering. So that was step 1. Step 2 is to evaluate all of those critical values in the original function. So we're plugging them back in here. If you plug in 0, 0 minus 0 is 0. Then we're going to plug in 2 and do that in your calculator, and you get -19.05. And then step 3, which you can kind of do in conjunction, is to evaluate the function at the endpoints. So at -1 and 8, so at -1, so f of -1, again, a calculator problem, and f of 8 is 192. Again, we did that in the calculator. Step 4, a maximum occurs when the y value is the largest of all of those. So let me color code the y's here. So these are all of the function values, so the y's. So the largest y is 192. That means there's a maximum there. So there's a maximum at x equals 8. That's the x value. And we'll state that it's an absolute maximum because that's what we're looking for. That's always the y value, 192. And then we also want to find the absolute minimum. So this is absolute minimum at x equals, let's see, the least value is -19.05. So that occurs when x is 2. And that absolute minimum is -19.05. So now take a few minutes, try the U-try, pause the video, and when you're ready, unpause it, and you will have your answer. Now that you've done that, we're going to look at another function. Clearly, that one was similar to the example we just did. So now we will look at this polynomial function. So first we take the derivative, and then we find all the critical values. So we're going to do that first. This is a relatively simple derivative. So this would be 12x to the third minus 12x squared minus 12x plus 0. And we want to find the critical values by setting that equal to 0. So 12x is a factor, and that leaves us x minus x squared minus x minus 1. And then this factors. Whoops, this was 24. So that's -2. Okay, that's better. Great. So our critical values are x equals 0 from that factor, x equals -1 from this factor, and x equals 2 from this factor. So we have our critical values. And that was step one. And step two is we evaluate the function at all the critical values. So we're going to evaluate the function at 0. And I forgot to check that they're all in that interval, but they are. So at 0, we get y equals 2. At -1, we get y equals -3. At f of 2, we get -30. Okay. Step 3 is to evaluate at the endpoints. So I need to evaluate the function at -2 and at 3. So when x is -2, the y is 34. And when f is 3, it's 29. Again, those were calculator steps. And the last step is to determine the absolute maximum. So again, I'm going to highlight my outputs here. Those are the values we're comparing. So there's an absolute max at the largest value. And the largest value is 34. And that occurs at x equals -2. And the maximum, the absolute maximum is 34. That's the y value. Then we have an absolute minimum at, let's see, what's the least value here? The least value is -30, and that occurs when x equals 2. So that minimum is the y value, which is -30. So now pause the video and do this try problem, and then start it again to find the answer. So there you have it. That's the answer to the try. Thank you for watching.